And we're going to be starting in terms of writing algebraic expressions. They're going to be expressions not with numbers, but with letters. Maybe some numbers involved too. And all algebra is arithmetic with letters. So if you know your arithmetic, then you know how to do algebra. Okay, the first word here is variables. And you have this all written down, but we need to understand this vocabulary. And a variable is something that changes. The weather in Minnesota is variable, right? 20 years ago today, we had the big Halloween blizzard. 20 years ago, you weren't here. It was 1991. And my daughter went out trick-or-treating. I lived on a farm, and I called the people who were taking her out trick-or-treating. I said, I think you better just keep her for the night because the weather's really bad to get back to my place. And they said, it doesn't matter. They were on their way back already. So she came home about 7:30, which was fine. And we didn't get out of the driveway for 3 or 4 days. We couldn't go down the roads where we lived because the snowdrift was as tall as the ceiling on the road. We basically had to dig out a tunnel.
Because you didn't have a key.
Nobody went anywhere in that time. And it was 3 weeks of driving on compacted ice on the roads. And you could only go 20 miles per hour. It was just awful. For weeks. For weeks. It wasn't just for a day or so. 28 inches of snow. And then what did we get? Then we got a whole bunch of snow on Thanksgiving. I believe it was Thanksgiving. And that was the last of the snow the whole season. That was weird.
Wait, didn't it snow in December?
Nope. We only had the 2 storms. Might have been a little light stuff, but nothing like last year was a lot of snow here. So the weather in Minnesota is variable because it can be like almost 60 today, which is really nice. But the East Coast ended up getting all that snow that we didn't get. So when I want to represent something that changes, I'm going to use a variable, and I'm going to use a letter. And most common letter is probably X. I don't know why. An algebraic expression, okay, variables used with one or more math operations. Add, subtract, multiply, divide. There's other operations out there that you're not familiar with. But those are the ones you know. And when you see a 2m, it means 2 times m. Okay, it's an expression. It's a math phrase. There's no equal sign. It's not a sentence. It's just a phrase. 3 times a number. That's it. Factors, those are numbers you multiply together. The terms and quantities being multiplied together. So and we've seen this word, factors of 6 or 6 and 1 and 3 and 2. Those are numbers you multiply together. We call it a raised dot. The dot here is, I guess it's not on the, it's like this, 3 times 2, that's a raised dot. 3.2 is a decimal point. Okay, so how do we do multiplication in algebra? There are a lot of ways to do it. Most common way you're going to see is the very first one, which means x times y. Rarely will you see a dot. You might see parentheses, any combination of the parentheses we have there. So to me, there's really only 3. When you multiply 2 numbers and 2 variables, use parentheses. It could be 1 in a parentheses or just or all of them. We don't use this times symbol because is it an x or is it a multiplication symbol? So I wish we never ever used an X for multiplication. So you use a dot or even parentheses way back when you were little, then we would never have any confusion. Okay? Now, we have exponents. Oh, that's another operation. Exponents. So we do know another one. This is called the base, and that's the exponent. And we've done some of this, like 2 to the 3rd power means, what does it mean? What does that mean? 2 to the 3rd. 2 times 2 times 2, which is not 6. It's what? 8. Okay. So x to the n, this is called a power. And if I have x squared, means x times x. Keep in mind that x just stands for some number. X could be 2. What if x is 3? Then we would have 3 squared, which is 3 times 3, which is 9. What I like about algebra, this isn't tough arithmetic, is it? Okay, 4 to the 6th means 4 times 4. How many 4s am I going to multiply together? 4 to the 6th. You should have 6. Does anybody know what 4 times 4 times 4 is? 16 times 4 is, do you know? It's big. It's 64. And then this one would be 64. It's still multiplying, and I don't know what 64 times 64 is, but I do know that 60 times 60, I can multiply the 6's together and get 36, and then there are 2 zeros. It's going to be somewhere around 3,600. It's going to be bigger than that, actually. But I don't know exactly. And before we do 6a to the 4th, let's just do 6a. What does 6a mean? That means 6 a's are added. So it's a plus a plus a plus a plus a, 1, 2, 3, 4, 5, 6. So the number in front is called a coefficient. It comes from Latin. My Latin background pays off once in a while, which means to come before, literally. So it's the number that comes before the variable. So 6a to the 4th means 6 times a to the 4th. So it's a times a times a times a. And I don't want to write it as repeated multiplication, but I have 6 of these guys. So we have to understand that if the number's in front, it's repeated addition. So when you have 3 times 2, that means I have 3 2's added up. And what if I have 2 times 3? That means 2 3's added up. And here's what's interesting. What's 2 plus 2 plus 2? 6. What's 3 plus 3? 6. So the order in which you multiply doesn't matter. There are things when it does matter, the things we don't know about yet, called matrices. And the word for this property, which I'm not going to ask you to know, is commutative. And the way I can remember it is just like commuting to school. You go to school from home, and then you go from school to home. It doesn't matter. It's the same path. You get the same results. So that's the way you could think about it. But I'm E there. Whoops. Okay, so that's just what these things mean. And you're going to be asking me a couple times. Like 2x means twice a number or x plus x. Because that's what the 2 means. X added up 2 times. Okay. Generally speaking, when you say of, half of a number, it's a multiplication problem. So if I want to show half of a number, she wrote down 0.5 times x, but she didn't put the parentheses in. That's what the 0.5x is. You could have 1/2 times x, which is the last one here, or you could take the number and divide it into 2 equal parts, because that's what a denominator means. Now, the problem with of is it does have multiple meanings. So if I combine it with another operation, like it says the sum of 2 numbers, that doesn't mean multiply. Sum means multiply, add. So mostly it's like half of something. I think you'll recognize it. Okay, let's do this. You got the next page? Oh yeah, we're going to collect this packet, by the way. So you need to be doing some of these things, and there's not much there. These are really your notes right there. So on this one, let's put these words in the right place. Anybody want to come up and do it? You want to come up and slide some words? So times is an easy one, isn't it? There you go. Good. And the divided by order is going to matter there. But multiplying or adding, order does not matter. Okay, good. You're doing all right? Okay, who wants to come up and do some more? Who's tired? Come on up. So tired, it's Monday. We had all weekend to rest, right? I think what I did. Oh, I went to the Gopher game. That was a good game. Good. Product also means multiply. Total comes in from what though? What operation? If you go to the store and your total bill is, what did you do? Yeah, you added. Make sure you write these down in the right place so that when you, do you need a pencil? So when you end up doing your homework, which is going to be doing stuff like this, increase by, quotient, oh, he's knows some big words. Divided into. There you go, good. Now, subtraction and division are tricky because order matters. So we're going to have to worry about the less thans, what's going to happen with less than. It won't matter for addition, you can do that wrong and get the right answer. No, decrease by. Yeah, there you go. He knows all his words. This is good. And all, again, is another thing like total. I have $5 at home, $5 in my purse. How much do I have in all? And then what's is? That's equals. Okay, so when you see the word is, that means equals. So you should write these down in the right boxes. Unless you're going to print out the notes offline, you can. And I'll put them up. However, whatever works for you. Sorry. Dean, do you have yours written down now? Or you could put the signs over by the words, too. That works. So we're going to try to write some algebraic expressions. I've got quite a few things for you, one little homework assignment. So, first thing is you have to define what you want to call this number. I want to write something that means 3 times a number, any number, it doesn't matter what the number is. What do you want to call the number? You want to call it x? Okay. I might have called it n, but let x equal my number. Okay, so we'll use that throughout the whole thing. What's 3 times a number? How do I write that?
3x.
3x. Love algebra, it's so much easier. So you turn the page. So write it down. Now, more than switches the order. So I have a number. I have so much money in my pocket. Actually 0, but anyway. And I want to get 4 more than that. Well, I'm going to start with the number first and then add 4. I could write this also 4 plus x. The problem is if it's subtraction, I can't do that. What's number 3? Adam, do you know what 3 is? Product. What does product mean? What does product mean? Production line. No. Product goes right here. Multiply. You've got it in your little chart. So product of 6 and a number. So how do I write that? 6x. That's what that means. You don't have to put the dot there. You can if you want. Generally speaking, we're not going to write that down. Okay, Keaton, I want you involved. The difference of 9 and a number. Now that's not really giving me the order. So I would take this either direction. What does difference mean? Subtract. So you could do 9 minus x, or you could do x minus 9. Generally speaking, when I find the difference between 9 and some other number, I want the positive answer. And I don't want to use absolute value symbols because it's enough just to do this. So I'm not going to worry about the order on the word difference. Either it'll be clear, or I'm just not going to worry about it. Okay, this one's hard. Twice the difference of a number and 3. I want twice the difference between 6 and 3. What are you going to do first? Let's do numbers first. I want twice the difference of 6 and 3. So I have $6. Corey has $3. What's the difference? How much? Difference. 3, because what did you do? You subtracted them. So I would go 6 subtract 3. I got to do that first. So what kind of grouping symbol do I have to use? I can't just do this, because that doesn't mean that. That's twice 6 subtract 3. I must use parentheses. Remember, order of operations, we have to do the subtraction first. The only way for that to happen is to put it in parentheses. So that's hard. So what am I going to write over here then? Twice the difference of a number and 3 is going to be 2 times, and you have to subtract your number, x minus 3. And this is harder than what you're going to do tomorrow. Tomorrow you're going to actually substitute values in. That's a lot easier. But coming up with these expressions is not easy. 6 is really not easy either. Let's change the problem to 10 less than twice 7. Let's do that one first. Because I think if you have numbers in front of you, you'll know what to do. I want 10 less than twice 7. What has to happen first?
4.
That's right. How'd you get that? Okay, so you did 2 times 7, and then you did what?
Equals 14 minus 10.
Then you subtracted 10. 14 minus 10. The less than, now less is, that's not true. It's the than switches the order, and you have to do this first. So twice a number would be what? 2, any number, call it x. 2 what? X. And it's 10 less than that is minus 10. It is not the same as 10 subtract 2x. Order makes a difference. And I think we're going to have some problems with that, because that's always hard for everybody. The word than switches the order. Same thing with here. 4 more than, I have to start with the number first and then add the 4. But I get the same answer even if I do it wrong. I'll give you full credit, because that's just as valid as that, so it's just as good. Okay, ready? Yes, no, ready? Okay, and there's the notes on that. The than and from. Switch the order. 7 less than 10 switches that. 6 subtracted from means you start with 12. And if you think about it, I think if you think through here, you'll be okay. 6 subtracted from $12 in my account means I'm going to do 12, take away 6. I think that's in your packet. I tried not to put extra stuff in there. So now we're going to let you have a little practice here. We'll maybe do a couple of these. First 2, and then let you guys try them and walk around and help you. And there they are. What would you like to call your number? And anybody can use whatever letter they want. It doesn't have to be X, but you better tell me what the letter is. What do you want to call the number? X? Boring. Okay.
You can do N if it makes it better for you.
N, or you could do C for Corey.
Sure.
But X equals my number. It doesn't matter. You can choose whatever you want. Now, what does 2/3 of mean? What's 2/3 look like? It's a what? It's a fraction. 2/3. What's the of going to tell you? Add, subtract, multiply, divide. It's going to be what? Multiply X. That's it. you're going to try these, and we're going to come around and help you. But let's do number 2, and I think I'll let you try the rest of them. And the homework is just a little half sheet of paper doing some of these. We'll do the substitution. Well, I could teach it all today and with time tomorrow. But I won't be here tomorrow. Okay, it says 3 times, that's a time sign. I'm almost going to translate this directly. The sum. What does sum mean, really? It's the answer after you've added. So when I do the sum of a number and 1, I got to do that before I multiply by 3. I got to get the answer. So I have to use parentheses. Oh, I don't want to use x, but the number is x plus 1. So how would I write that? I would do 3 times the number x plus 1. I have to add these and then multiply by 3. Sometimes it's easy just to translate it. So I'm going to pause the recording and give you a chance to try these, and maybe somebody can come up and put their answers up here. Let's see. Is that all there is? No, there's a little bit more. So try these, and it should go on your worksheet. So I've been doing that. Okay. And this is actually correct because of the than actually switches the order. So we've got 3 more for you to try. Uh-oh. And that's where you're going with algebras number 9. Okay, so let's look at the next one. 30 less than half of a number. So what if my number is 10? What's half of 10? 5. What'd you divide by? 2. So I'm going to take my number, x, and divide it in half. So I'm going to divide it by 2. Or you could have written 1/2 x. A lot of you wanted to divide by other things. Half is 1/2 times my number. And then it's 30 less than that. So what happens next? 30 less than minus 30. Less means subtract, and we have to switch the order because of the than. That's why it's highlighted. So that from is also going to be highlighted. No, I can't separate that. Okay. 17 subtracted from 4 times a number. What do you have to do first? Read it again. 17 is subtracted from 4 times some number. What if it's 4 times 10? What if my number is 10? What would you do first? Always go back to numbers. What's 4 times 10? 40. And then what would you do? Subtract 17. So you would do 4 times 10, if that was my number, and then you subtract 17. So I have to do this first. 4 times a number is what? Any old number. Is 4 times x. And then we're going to subtract 17. That make a little more sense? Not easy. I thought the last one was hard. And the last one I'm going to draw a picture because I love pictures. It says the area of a rectangle. No, let me get a rectangle here. There it is. Cheating. I love the cheat, Keaton. The sides are x and x minus 3. So if this side is x, then this side is x minus 3. What if this side is 10? What would this side be? Evan, if this side's 10 and this is x minus 3, how big would this side be? What does this x minus 3 mean? Take your number and subtract 3. It would be 7. That's right. Do you remember how to find the area of a rectangle? If you're going to do any work in your homes, when you get a home or apartment someday, you're going to have to know this. The area of a rectangle is length times width, and you've been taught it for many, many years. So the area here is the length and the width. It doesn't matter which is which. It's x times x minus 3. Do I need parentheses? Do I need parentheses there? Yes. I call it in calculus the case of the invisible parentheses. You have to have those parentheses. We're not going to learn what to do with x times x yet. That's all you had to do was write this. So that was a little bit harder. Oh my goodness, we're almost out of time. These are those properties. I'm not worried about them. I may come back to them. I just put them in there just for fun. Okay, that should be my, that is my last slide. Okay, so you have just a little bit of work, and you can finish it tomorrow, but some of you have to finish your quizzes tomorrow. So you're going to try this, and then we're going to, I think I have an extra copy for you. Because I had to print this off the regular printer. I don't know if the copy machines are going yet. And actually, it shouldn't take you that long.